Welcome to the final exam, question number 33, and it has a diagram on there. It says, which of the illustrations on page 179 best represents the components of the reactions acting on the structure shown above? And I'm going to go ahead and reproduce that right here. And let's put in, this means it's fixed right there. Then we have a pin, and then another pin. Coming out here, and then it looks like we have a bit of overhang here. Alright, and then we also have a load coming down here. Let's just give it a name P. C, that's point B, that's point A, and that is D. And I'm guessing I'm going to take a quick look. It has reactions. So let's go ahead and figure out what the reactions are. It's going to be, pin reaction has two reactions. It has a positive and a, well, let's just say it has an X and a Y. So it's going to be up or down and left or right like that. So we have to figure out which reaction is that. Remember, pins allow rotation. So to do that, I'm not going to look at the answers. I'm going to go ahead and draw in what I think is correct, and we'll see if one of the answers matches what we have. And when you look at this, there's a few ways you can look at it. What I like to do is just pretend that one of these is kind of not there. Some of the things aren't there. What would happen if you applied this load? And the first thing I would do is say, okay, if this was just sitting there, so you hold this point. Let's say there's nothing here. What would happen if you pushed it there? You held this pin, so it's allowed to rotate, and you came down here. It's in my mind, it's going to move like that. I think that makes sense. So if you have that motion, what's going to resist that? And I think the obvious one is, well, this is definitely going to come out here. And since looks like you're also going to have like so. And I hope that makes sense, because this is coming at an angle, so it's going to be coming down like that. So you'll have both. It'll be coming in like this, and then you'll have a component like that, and a component coming down as well, like this and that. All right. So that's that. Now let's take a look at this. Let's do the same thing. Now let's hold a pin right here, and let's let this be free. What would happen if you push down here? Well, in my mind, if you did that, it would come down like this. So if you think about it, you would have to keep it there, you'd have to have a force going that way. And I guess the more difficult is, what is your vertical force? You can see your horizontal force needs to be in. Now, what is your vertical force? And I think that's a little bit more difficult, because it's right over there. Now, how else could you figure that out? I guess what I would think of is, if you didn't see this down here, if you kept a pin right here. Let's actually do that. You kept the pin right here, what would happen? And my thought process is, if you push down on this would want to go up. So to keep it, you're going to have to push it down. Does that make sense? So if you did push down on this, and assume it's rigid, it's going to look like it's going to deflect like this. So to keep it at the point it is, you're going to have to push it back down, and that's the way the reaction is. And that's how I always think of reactions, is if it's going to move, well, I have to resist that force by pushing it back. In other words, let it move, then push it back, and that's your reaction. And I believe, let's see if that's the answer. Alright, and your answer, it looks like, is B. B looks like what we just drew up here.